All right, are you ready for more? Here is a circle centered at O with a radius of 1 unit. Line AB is tangent to the circle. Calculate the length of segment AB. So the first thing I'm thinking, let's make sure that I have labeled everything that they've mentioned in this problem. Circle centered at O with radius of 1 unit. So here's 1. I could label from here to here 1, but like if this whole segment AB is greater than that, it's not going to be super helpful to label partial of the line, part of the line. And line AB is tangent to the circle. Well, that's very important. If this is tangent, I know that we've got a right angle here. So I can say that triangle AOB is right. So if I want to calculate the length of a segment AB, well, how do we calculate the missing side of a right triangle? That's going to take us back to trig. All right, so this will be good review, although that's still a while away. You know, those of you taking Algebra 2 next year, there will be substantial amount of trig in that class. Okay, so what I'm going to do now is, here's my reference angle, right? That's the first thing we want to talk about, is that 50 degrees. So I want to find this side AB. So I noticed that in relation to 50 degrees, that would be opposite. This is my hypotenuse, because it's opposite the right angle, and then 1 would be my adjacent side. So if I have the adjacent, I need the opposite. Opposite over adjacent, that means we're going to use tangent, which is, you know, of course, another word for a line that only intersects a circle at one point. So let's set it up. Tan of theta is equal to opposite over adjacent. So theta being my reference angle, that's 50. So tan of 50 is equal to opposite. Opposite would be x, and adjacent would be 1. So this is a pretty simple one because x divided by 1 is just x. So I'm just going to go ahead and plug tan of 50 into my calculator. Before I do that, because I'm sure some of you have not done trig in a while, you're going to want to go to mode, and you're going to make sure that you're in degree mode, not radian. And we will talk about radians actually later in this unit, so hold on to that. Okay, so tan of 50. All right, that is 1.19175, so I'll just say that this is equal to about 1.19. I don't know why this textbook never tells you where to round to, but that would be about 1.19. How does the length of segment AB relate to the tangent of 50 degrees? Why is this true? How does it relate? It's equivalent to tangent of 50 degrees. Why is this true? Because tangent lines form right angles with radii. Okay, number 3. In right triangle trigonometry, tangent is defined in terms of side ratios. Write another definition of tangent in the sense of a numerical value, not a line, in terms of a circle with radius 1 unit. Okay, write another definition of tangent in the sense of a numerical value, not a line. Okay, I mean, I guess I'm not really sure what they're trying to ask here, actually. Let's look at the diagram. So I guess what we found here was that, I mean, x ended up being our answer, right? Just that value of x. So I guess what we could say is if you have a central angle, where the two rays intersect a tangent line on the circumference and off. So what I mean by that last statement, it's intersecting the tangent line on the circumference, and then one of the rays is intersecting the tangent line off the circumference. I don't really think this is worthwhile, but then the distance between the two intersection points is equal to tan of the central angle. So I guess what they're trying to go for here is, let's say, like, maybe it's got to be a radius of 1. So let's say maybe you and your friend are going in different directions, and you know the angle at which you depart at, which would be interesting to know that. And you walk 1 mile away. You could find out how far away you are from your friend by taking the tangent of whatever angle you departed at. It was actually, I'm sorry, that is sort of an interesting idea to think about. I'm sure that is how you can sort of predict where someone's going to be. Yeah, so I guess that's what they're trying to go for here.